Hello, my name is Artur and today I will be showing you my third design of an Arduino compatible watch. So this is actually the third watch I designed. This was the first one, which used this Nokia display, and this was the second one, which used a display from an old Polish calculator. And as you see, the major difference with the new watch is that it has an always-on display, which is very convenient, and it can actually keep showing the time like this for about 5 days on a single charge. This display is Display Vision's DOGS 102, the transflective version. So it actually has a backlight, which makes it very practical because you can see it in full daylight as well as in complete darkness, where you can just press a button. Another major difference when compared to the previous watches is the size. As you can see, it is much smaller than the two previous watches, and it is actually also more lightweight, which makes it overall more comfortable to wear. So if I get a scale, I can actually show you how much it weighs. So this is a third watch, which is quite thick and bulky. And as you see, it weighs about 77.5 grams. This second one weighs about 76.8. And this one is just 40 grams. This is actually a bit lower than this standard Casio watch, which I was wearing before I developed my own watches. As you can see, it is smaller than my watch, but because this watch has the case made of plastic, it makes it actually slightly more lightweight. And although it is kind of big, you don't really feel that it's big because it weighs the same as a small watch like this one. So let me show you the features of this watch. So here you can see it is an off state where the display backlight is turned off, and actually the microcontroller is in deep sleep, and the microcontroller wakes itself up every 8 seconds to update the display and then goes back to sleep. So in this state, the battery can last about 5 days on a single charge. If we want the backlight, I can just press this button and it will show the backlight for about 2 seconds. To access all the other features, you have to put the watch in the permanently active state. So you have to press these two buttons at once, and now it has woken up. To access the menu, I press this button, and I can navigate around the menu with the rotary encoder. So the first option is setting an alarm, which is quite easy. You just use the rotary encoder. So I can set an alarm for 2 minutes from now, which will be 15:45. And we will see what happens. As you can hear, the watch is vibrating now. It has a vibration motor inside, and I can just disable the alarm by clicking this button. Let me wake it up again. And here you can see the AL icon. I can use this button to enable and disable the alarms. So the second feature is setting the time, which is again quite easy to do, similar to the alarms. Use the rotary encoder and select the different options for the date, time, and year. The third option is a timer, which you can set a number of minutes and seconds. So I can set it for 0 minutes and let's say 10 seconds. I can start. I can stop the timer, which stops it at the current time. I can also reset it, so like set it again. And if I let it go, it should vibrate when it goes to 0. And yes, you can hear it vibrating now. So I stop it by pressing the stop button, and I can leave the timer by pressing here. The next function is stopwatch, where I can start the stopwatch, stop it, and I can start it again, of course. And I can then reset the stopwatch. So it shows the minutes, seconds, and milliseconds. The display can't refresh fast enough to actually show the advancing milliseconds, but it is actually counting the milliseconds. So if you stop it, it is showing the correct number of milliseconds. Yeah, and the next feature is setting the contrast, which I have set at 8 here. I can make it higher or lower. But I found 8 is a nice value, and actually the contrast setting is saved in EEPROM. So when you reboot the watch, the contrast setting will be loaded from EEPROM, so that you don't have to set the contrast every time. So let me show you what this watch looks like inside. So this is the top part. This is a piece of plastic. I am just using it as a screen protector. And here you can see the main board. As you can see, the watch has 4 buttons, a rotary encoder, and also an on-off switch. This is a global power switch, which can be used to turn off the entire device when it's not in use, so like for storage, and also for resetting the microcontroller. As you can see, there is a USB Type-C port, which is used for both charging and programming the watch. And here you can see the battery, which is a 250 milliamp hour LiPo. You can see the 4 buttons. This is the vibration motor, and it is actually stuck on top of the microcontroller, which is an ATmega 32U4, just like the ones here. It has 2 buzzers connected in parallel to increase the volume. Here there is a battery charging circuit, as well as voltage regulator, which provides 3.3 volts for the whole watch. And this is a WinBond 8 megabyte flash chip, which can be used for storing useful things. which won't fit in the 32 kilobytes of program memory of the microcontroller. The PCB was designed in easy EDA and manufactured, as you can see here. And I soldered most of the components using a hot air soldering station, although some were soldered using just a fine tip regular soldering iron. The timekeeping is done by a DS3231 real-time clock, which is positioned under the buzzers here. So let me assemble this again. As you might have noticed, this watch has two piezoelectric buzzers, which can be used to play simple tones. And actually, when the watch is woken up and I press this button, you can see this icon appear. This basically turns on and off the tone playing functionality of the watch, and when this icon is on, the watch will use the buzzer instead of the vibration motor to play sounds. For example, when there is an alarm or the timer is up, which I can show you. Setting a time for, let's say, 10 seconds. And it plays Bad Apple, because why not?